Hello everyone, and welcome to Network Labs. Today in this video, I will show how to configure AS-PATH Prepending using prefix-list and route map to manipulate the inbound traffic of the customer. In BGP, the best path is chosen with the shortest AS-PATH length. It is done by adding own autonomous system number multiple times, so the AS-PATH becomes longer. This is called AS-PATH Prepending. In the diagram using AS-PATH Prepend, the customer's inbound or download traffic will be manipulated using its assigned public IP addresses. For our task, customer's public IP1's primary path is via ISP1, while public IP2's primary path is via ISP2. If either of the link or ISP fails, traffic must divert to the other and vice versa. Here, we will be checking the output of the Internet router, since the traffic that we are influencing is the inbound of the customer router. By default, in the Internet router, to reach the customer's network, it chooses ISP1 as the best path due to lower neighbor IP address. Let us conduct trace route in the Internet router, going to both PC1 and PC2. Based on the trace route results, the best path to reach the customer routes is via ISP1. Also, the same AS path length to reach the customer is seen. Now, let us proceed with the configuration. First step, configure prefix list for both ipv4 and ipv6 public IP addresses of the customer on the border router. BGP is already configured and working on the router with the default behavior. Enter the global configuration and start with prefix list. Type IP space prefix list, then the desired name. Followed by permit. Then network address. You can input the exact network address or use an operator to be more flexible. Here, I choose LE, which means all networks from /24 until /32 are permitted. Repeat the same configuration for the other prefixes. For IPv6, change IP to IPv6, then prefix list, then name, followed by permit and the network address. Similar with IPv4, I use LE operator and permitted the networks that fall within /48 to /64. Prefix list for both IPv4 and IPv6 are configured. Let us continue and configure route map for each prefix. Enter the configuration mode. Type route map followed by the desired name. Then permit and the sequence number. Under the route map, match the prefix list. Then, set the AS-PATH prepend value. It is a good practice to use your own AS number to avoid conflict in the Internet. Here, let us prepend the customer's AS twice. Make sure to allow the other prefixes by creating the same route map with higher sequence number. Similar configuration for IPv6. Create a route map and match the IPv6 prefix list. Then the same prepend value. Public IP1 is done. Create 2 more route maps for public IP2, for IPv4 and IPv6. Route map configuration is done for the two public IP addresses. The last step is to apply those route maps under the BGP for each address family. In BGP, when the policy is applied outbound, the inbound traffic is influenced. When applied inbound, the outbound or request traffic is influenced. For public IP1, the primary path for the inbound traffic or download is ISP1. To achieve this, apply the route map outbound to ISP2 neighborship. For public IP2, the primary path for the inbound traffic or download is ISP2. To achieve this, apply the route map outbound to ISP1 neighborship. Enter the BGP configuration. Then, under each address family, apply each route map to each peer. Let us start with IPv4 peer facing ISP2, to which we will apply the route map for public IP1 outbound. Next is the IPv4 peer-facing ISP1 and apply the route map for public IP2 outbound. Exit the IPv4 address family and enter IPv6 address family. In IPv6 peer-facing ISP2, apply the route map for public IP1. Then in IPv6 peering with ISP1, apply the route map for public IP2. Configuration is complete. Let us verify and check the updated route in the Internet router. For updated routing table, reset all the BGP connections. Going back to the original BGP routing table to reach customer's network, the best path is via ISP1 for both IPv4 and IPv6, and ISP2 as the backup. Now, for the new BGP routing table after the AS-PATH prepending is configured in the customer router based on the requirements, we can see that the path is already updated. As desired, to reach the customer's public IP1, the best path is via ISP1, since the AS-PATH length via ISP2 has increased by 2. While to reach the customer's public IP2, the best path is via ISP2, since the AS-PATH length via ISP1 has increased by 2 also. the same expected result for IPv6 BGP routing table. To validate the route, let us conduct a tracer route from the Internet router going to both PC1 and PC2. As desired, the trace route results are matched with the customer's requirements. Now let us check the failover if it is working. First, shut down the port in the border router facing ISP1. In the Internet router, both the customer's network are still reachable, and the best path is now via ISP2. Next, shut down the port facing ISP2 in the border router. As expected, the best path is now via ISP1. In this task, for AS-PATH Prepending, we have created a prefix list to each network for IPv4 and IPv6. Then applied each prefix list to their respective route map. In each route map, AS-Prepend value is configured based on the requirements. Then, in each address family under BGP, each route map is applied outbound to each neighbor. I hope that this is informative to you, and thank you for watching.